Hello, good day, students. I know it's already late that I sent this video to you, and I hope you're still doing fine. And yeah, let's talk about the hydrocarbons today. Okay, so let's go. Hydrocarbons is one of the simplest compounds in organic chemistry. It is because hydrocarbons are composed or consist only with these two elements, and these are the hydrogens and carbons. From the word hydro, this is where the hydrogens came from, and the carbon, which is the carbon itself. So that's why it is called hydrocarbon. It is because it is the mixture of hydrogens and carbons. Now, each element, specifically in hydrocarbons, has its maximum number of bonds. For hydrogen, it has one maximum bond, and for the carbon, it has four. So, dili siya pwede mo lapas siyang maximum bond sama sa gibutang dira. Maximum means it is the highest level or the maximum, right? Okay, now the bond what I'm talking about is something like this. Okay, if you still remember your grade 9 subject, specifically, I mean your grade 9 topic, specifically in Lewis structure, so ingani ang forma. Okay, now hydrocarbons are categorized with these two types. The first is aliphatic and the second one is aromatic. Now, in aliphatic, it is divided into different families. The first family is alkane, the second one is alkenes, the third one is alkyne, and the last one is called cycloalkane. Now, we're going to discuss only these two hydrocarbons, the alkane and alkene. Okay, so the properties of hydrocarbons, specifically in aliphatic hydrocarbons, are these. For alkane, it has a single bond. So if you're going to write a Lewis structure, therefore, you must have a single bond like this one, okay? Now, in order for you to get the molecular formula, you must use this equation. CnH2n plus 2. Okay, so you're going to use that equation for you to get the molecular formula. Now, in naming the hydrocarbon of alkane, you must use the suffix ane for you to determine if it is alkane, alkene, or alkynes. Okay, now for alkene, it has a double bond, and the equation that you're going to use is CnH2n, and the suffix will be ene. Now, for the alkynes, it has a triple bond, and it has an equation of CnH2n minus 2. The suffix for the alkyne will be YnE. So you must remember these things in order for you to determine of what type of aliphatic hydrocarbon will it be. Okay. Now, if there is a suffix, there is also a prefix. In prefix sa hydrocarbons, it is based on the number of carbons that is present or that are present in a compound. Now, if if a compound has a carbon in it, then you must use the prefix meth. If it has two carbons, then use eth. If it has three prop, four but, five pent from penta means five, six is hex from hexa, seven hep, eight oct, nine non, 10 dec, 11 on deck or on deck, 12 is dodec, 13 is trideck, 14 is tetradeck, 15 is pentadeck, 16 is hexadeck, 17 is heptadeck, 18 is octadeck, 19 is nonadeck, 20 is icus, 21 is henacus, 22 is ducus, 23 is tricus, 24 is tetracus, 25 pentacos, 26 hexacos, 27 heptacos, 28 octacos, 29 nonacos, and lastly 30 is triacont. Okay, so these are the prefixes that you're going to use for you to name the hydrocarbon. Okay, now let's focus on the alkane first. In alkane, in order for you, I mean, if you're going to draw the structure of an alkane, then you must use a single bond or single bonds, okay? That's the indicator of being an alkane. Now, in getting the molecular formula, you must use the CnH2n plus 2, which is the equation of alkane. And in naming, you must use the suffix A N E. Okay, now let's have an example. So, for example, the teacher gave you a compound that consists only one carbon and it has a mixture of carbon and hydrogen, so it is a hydrocarbons. Now, the teacher wants you to identify the name of the compound, to get the molecular formula of the compound, and to draw its full structure. Okay, so how are we going to do that? Now, let's focus first in getting the name of the compound. Okay, so for you to know the, I mean, in order for you to identify the name of the compound, you must get first the number of carbon that is present in the given compound. So if you're going to read it again, hydrocarbon compounds that contains one carbon. So the hint here is one carbon. Now, after getting the number of carbon, you must get the equivalent prefix of it. So the equivalent prefix of one carbon is meth. So that's why I write the word meth. Now, therefore, write the prefix first in order to identify the name. Third, after putting the prefix, add the suffix. Since we are talking about alkane, then we must use the suffix nga, a, and e. So add a and e to the word, and the name of the hydrocarbon compound that contains one carbon under alkane is methane. So that's how you are going to identify the name. Okay, that's for naming. Now, let's go to the second one. What is the molecular formula of the compound? Okay, let's just have this one. Okay, so the given here is methane. Methane has one carbon. So the second um, the second thing that you need to get is the molecular formula. Okay, so in order for you to get the molecular formula, you must use the equation na CnH2n plus 2. So this is the fixed equation in getting the alkane, okay? So take note of it in getting the alkane. Now, the letter N here, the letter N is represents the number of carbon that is or are present in a compound. So in methane, there is only one carbon atom. Therefore, the N here will be substituted by number 1. Okay, so it will become C1 H2 open parenthesis substitute the n to 1 plus 2. Now, after this one, you are going to multiply the 1 to 2. So C1, 2 times 1 is equals to 2. Then plus 2. After that, copy C1, add this thing, it is equals to 4. Now, If it is only one, the subscript is only one, there's no need to write. Therefore, it will be CH4. And CH4 is the molecular formula of methane. Gets? Okay, so that's how you're going to get the molecular formula of an alkane. Now, let's proceed to the third one. So what is the full structure of the alkane or methane? So there are, these are the steps in getting the structural formula. Now, all we need to do first is write the carbons. Okay, let's go to the second page. Now, in getting the full structure, okay, in getting the full structure, you need to write the carbon first. In methane, the given is methane. Now, how many carbons are there in methane? Okay, it has only one carbon, since from the word meth is equivalent number to 1. Therefore, the methane has a 1 carbon. Now, the first step is write the carbons. So this is the carbon. Now, the molecular formula of methane is CH. The molecular formula of methane is CH4. So there is one carbon and four hydrogens. Now, in writing the molecular formula, this carbon is surrounded by hydrogens. Okay, so the number of hydrogens in the methane is 4. Therefore, we're going to write four hydrogens here. One at this side, one at the other side, one at the top, and one at the bottom. So this is the full structure of methane. Okay, got it? Okay, good. Now, let's proceed to the second one. So this is how you're going to get the full structure. And I hope I discuss it very well so that it aids the confusion. Now, let's have another example. The example here is a compound that contains 3 carbons. Okay, let's proceed to number 3. Example number 1. Number 2. Okay, example number 2. The teacher gave you a compound that contains 3 carbon atoms. Now, the things that you need to look here are the name of the compound, molecular formula. So let's put it here. Find the name, full structure, not find, this is draw. Okay, I'll just identify the name. Next one is identify the molecular formula. Molecular formula. And lastly, the full structure. Draw the full structure. Okay, so these are These are the things that you need to identify and draw for this example number 2. Now let's go to the identifying the name first. So example number 2. Okay, now the name. So first thing you need to do in getting the name of the compound is to identify the number of carbon first. Now, the given here in example number 2 is it has 3 carbon atoms. So we need to write 3 carbons. So since we already knew the number of carbons, then we must get the equivalent prefix of number 3. So if you're going to check the prefixes, so the 3 is equivalent to prop. Okay, so we need to use the word prop. So first thing you need to do after identifying the number of carbon is write the word prop. Now, the next one is identify the suffix. Since we are talking about alkanes, then the suffix of the alkanes is A N E. So we are going to add the word A and E. So this is the name of a compound that contains, I'm sorry, this is the name of the hydrocarbon compound that contains 3 carbon atoms, okay? It's propane. Now, let's proceed to the second one. Example number 2, the second mission is to get the molecular formula. Now, in getting the molecular formula is you need to use the equation CnH2n plus 2. Now, the n here is equivalent to the number of carbons. Since our given has a name of propene, since the given is propene and prop means 3. Therefore, the n here will be substituted with number 3. Okay? So C3H2 parenthesis, open parenthesis 3 close plus 2. After that, you must copy the C3, then H2. No. Multiply the 3 times 2. So it will be 6 plus 2. So C3H, 6 plus 2 is 8. So this is the molecular formula of propane. It is C3H8. This is the molecular formula of propane. Gets? Okay, I hope so. Let's proceed to the third mission. So, example number 2, get or draw the full structure. I'm sorry for the I'm sorry for the handwritten. Okay, now in getting the full structure of the compound propene, okay, again the compound is propane. The compound is propane. So prop means 3, and that number 3 is the carbon. So the first thing you need to do in drawing the full structure of the compound is you must put the carbons. And there are 3 carbons, therefore you must write 3 letter C's. Okay, that represents the carbons. Prop means 3. And ane is the prefix for alkane. Now, in writing or drawing the structure of an alkane, it must be a single bond. Therefore, these carbons are connected with a single bonds. Okay, that's a single bonds. Now, in every carbon, it will bring or carry hydrogens. Now, in order for us to identify the number of hydrogens, let's go back to its molecular formula. So the molecular formula of propane is C3H8. So let's write it here, C3H8. Now, there are 3 carbons and 8 hydrogens. Therefore, these carbons will carry 8 hydrogens. So I have a tip for you. I have a tip for you in order for you to identify the number of carbon easily. I mean the number of hydrogen per carbon easily. So if the carbon is at the edge or at the right or left side, these, for example, these carbon and these carbon, since it is at the end and the beginning, so these 2 carbons will carry 3 hydrogens. Okay, 3 hydrogens. And the other side will also carry 3 hydrogens. Okay, now the carbons that is in the middle will carry only 2 hydrogens. So to double check if it is correct, we must count the number of carbons and hydrogen. So the number of carbons here are 1, 2, 3. Therefore, it is C3. And the number of hydrogens are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 hydrogens. So therefore, this is correct. This is the full structure of a propane. Okay, yes? Okay, I hope so. Okay, let's go back to the PowerPoint. Okay, that's how you are going to get the full structure of an alkane. Here, this is the full structure of an alkane. Now, there are 2 additional types of structures that we are going to use, and these are the condensed structure and skeletal structure. Now, for the condensed structure, it is a system of writing organic structures in a line of text. For example, C4H10, C4H10. So, if we are going to draw the full structure, it will be something like this. 1, 2, 3, 4, C4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. So this is the full structure of C4H10, or it is also known as butane. Now, you must divide them based on every carbon that is paired with hydrogens for you to get the condensed structure. So this is the full structure of butane. Now we are going to divide them in every carbons. So the first carbon here has, it have three carbons. There are 3 carbons in the first, oh, sorry. There are 3 hydrogens in the first carbon. So we must write C, H, and the number of hydrogens are 3, CH3. Okay, the second carbon naa siya ay duha ka hydrogens, therefore CH2. The third carbon na siya duha ka hydrogens, therefore CH2. And the last carbon is na siya tulo ka hydrogens, therefore CH3. So the condensed structure of butane or C4H10 is CH3, CH2, CH2, and CH3. So this is how you're going to write the condensed structure of an alkane. Okay, get? Okay, let's proceed. Okay, skeletal structure. Skeletal structure is a type of a molecular structural formula that serves as a shorthand representation of a molecule's bonding at some details of its molecular geometry. So the skeletal structure is something like this. Okay. So mura siya letter M, dagan nga letter M, magbagis-bagis ra. Okay, let's have an example. C4H10. C4H10 is butane. The skeletal structure of C4H10 butane is something like this. So yung ani ang porma sa C4H10 10 nga butane. Now, let's have this thing. Okay, let's draw. Skeletal structure. Okay, the skeletal structure of butane, let's go first to its molecular formula. The molecular formula of butane is C4H10. Now, there are 4 carbons in this formula. So in order for us to get the skeletal structure, we must draw a letter M's. Okay? So 1, 2, 3, 4. So this is the skeletal structure of C4H10. Now, this is the hint in order for you to identify what kind of hydrocarbon will it be. So if you're going to write something like this, a skeletal structure, make sure that the number of edges is equivalent to the number of carbons, since these edges represents the carbons. Okay, so this is the first edge, carbon 1, carbon 2, carbon 3, carbon 4. So 4 carbons in this structure. Then the given is C4 and it has 4 carbons. And 4 in the prefix, the equivalent prefix of 4 is but. Okay, if you're going to check, let's have it. Wait a minute. Okay, so the number 4 is equivalent to the prefix but. So we must use the prefix but. Now, since it is only a single bond, if you're going to check this one, so it is a single bonds. Now, if it is a single bonds, therefore it is an alkane. An alkane has a suffix of ane. Therefore, we're going to add ane sa iyahang name. So, the name of this skeletal structure is butane or C4H10. Gets? Okay, I hope so. Now let's proceed. Okay, that's how you're going to write the skeletal structure. Let's have an example. Let's have an example. Okay, sorry. Okay, let's have an example number 3. Okay, the example number 3 is the teacher will give you a molecular formula of C10H22. Now, the teacher wants you to get the following: the name of the compound, you must get the name of the compound, the full structure of the compound, get the full structure. Next is get the condensed structure of the compound, and lastly the skeletal structure. So these are the things that we are going to identify or draw: the name, the condensed, the full structure, and the skeletal of C10H22. Now let's proceed to the name. Now, The molecular compound here is C10H22. So all you need to do in identifying the name, you must get the number of carbons. How many carbons are there? So C10. Therefore, it has 10 carbon atoms. And 10 is equivalent to the prefix of dec. Means deca, or deca means 10. So the first word that we're going to write in the name is dec. Okay. Okay, now, in order for us to identify it is if it is an alkane, alkenes, or alkynes, the prefix that we're going to use is we must manually check if we are going to use the suffix ane, ene, or yne. So let's check. So the suffix is, let's make it black. ane, ene, yne. Now, let's start with the alkyne first. The formula of alkyne is CnH2n minus 2. So the C here, the N, the C is followed by letter N, and letter N represents the number of carbons, which is 10. So C10 H2 open parenthesis 10 minus 2. So 10 times 2 is 20, minus 2 is 18. So therefore, it is not the same with the given. Okay, so it's C10H18 and this is C10H22. Therefore, we are not going to use the suffix YNE. Now let's proceed to the second one. The alkene has an equation of CnH2n. Now, the N is 10, H2, open parenthesis, 10. So 10 times 2 is 20. So the molecular formula, if we're going to use alkene, is C10H22, which is different from the given. So we are not going to use alkene. So let's try alkane. Okay, for alkane, it has an equation of CnH2n plus 2. So C10, H2, open parenthesis, 10 plus 2. So 10 times 2 is 20. 20 plus 2 is 22. So it is C10 H22, which is the same with the given. So we must use the suffix ane. So it is decane. Gets? Okay, here's the tip for you to identify it easily. Now, the given here is C10H22. Now, the tip here is you are going to multiply this carbon into 2. Okay? So multiplied it into 2. So 10 times 2 is 20. Now, if the number of hydrogens in the given is if the number of hydrogen is in the given is greater than the answer, is the indicator is this compound is alkane. So you must use the prefix ane. But if the number here is less than the answer, then you must use the suffix y and e if it is less than the answer. So if it's H18, so if it's C10, H18, so if you're going to multiply 10 into 2, it will be 20. So 20 is greater than 18 or 18 is less than 20, therefore it is alkyne. Okay, gets? Now, if it is H22, I mean CnH20, not Cn, but C10H20. So if we are going to multiply the 10 into 2, it will become 20. Okay, so if it is the same with the number of hydrogens, then you must use the suffix na E and E. It is because it is an alkenes. Okay, but if it's greater than the 20 or the answer, it is alkane. But it is less than the answer, it must be alkyne. Okay, gets? Okay, I hope so. Now, let's proceed to the second mission is to get the, we're done with the name. Okay, get the full structure. Okay, example number 3. And it is C10H22. C10H22. It is called decane. Okay, now in writing the full structure, you must write first the carbons. Okay, write first the carbons. Now, how many carbons are there in the cane? So it is 10. So we must write 10 carbons here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, since it is ANE, therefore it indicates that this compound is alkane. And if you are going to write a full structure of an alkane compound, you must connect these things, these carbons with a single bonds. Okay, single bond, 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 single bond. Okay, now if the carbon is, the carbon that will be on the edges, the right edge and the left edge, you must put 3 hydrogens. Let's change the color. Okay, you must put 3 hydrogens. 1, 2, 3. The same with the other side. 1, 2, 3. Now, the carbons that is in the middle, they must carry 2 hydrogens. 1 at the top and 1 at the bottom. So it's not even. I'm sorry for that because I'm really having a hard time making this structure using a mouse or cursor. Okay. So this is the full structure of a decane hydrocarbon. Okay, so let's check. Is this okay? Now let's count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 carbons, C10, correct? For the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There are 22 carbons. So this structure is correct. Okay. Now, let's proceed to the third mission is to get the condensed structure. Okay. Now, in condensed structure, we must base our condensed structure in every carbons. So the first carbon has three hydrogens. So we must write C, H, and the number of hydrogens are three. Next, the second carbon contains two hydrogens, so therefore CH2. Third carbon, the same, CH2. Fourth carbon, the same, CH2. Fifth carbon, the same, CH2. CH2. Another CH2. Another CH2. Another CH2, and lastly, the last carbon has three hydrogens. So the condensed formula or structure of decane is this one. CH3, CH2, 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 CH3. So this is the condensed structure of decane. Okay, now let's go to the skeletal structure. So this is still example number 3. So the formula here is C10H22. Now, get the skeletal structure. Skeletal structure. Okay, so in getting the skeletal structure, you must draw something like this. Now, let's check if it is already equivalent to C10H22. So, in order for you to check if it is correct, you must identify the number of carbons. So, there are 10 carbons in C10H22. 10 carbons. So, carbon in the skeletal structure represents the edges. So, let's count the edges if it is equivalent to 10. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 edges, therefore the name of this structure, skeletal structure, is deck means 10, and then it has only single bonds, therefore we must use the suffix ane. So this can be read as decane. Okay, gets? Okay, I hope so. Now let's proceed to the second type of aliphatic hydrocarbon, which is called alkene. Now, in alkene, in drawing, you must use double bond, and it has an equation of CmH12, H2N. And in naming, you must use the suffix ene. Okay, that's how you're going to use it. Now, let's have an example. Okay, but before that, please take note that the prefix meth in alkene cannot be used in this type of hydrocarbon. It is because it doesn't exist or it cannot be applied. So, walay meth sa alkene. Okay, let's have an example. So the given here is a compound that contains two carbon atoms. A compound, specifically an alkene compound, that contains two carbon atoms. Now, get or identify the name of the compound, what is its molecular formula, what is or draw its full structure, and condensed structure. So these are our missions. So let's go first in getting the name of al- two carbon two carbon atoms that is in alkene compound. Now, in naming, first count the number of the carbons and write their equivalent prefix. So the given here is two carbon and hydrocarbon compounds. So we must use the equivalent prefix of 2. So the equivalent prefix of 2 is if. Therefore, we must write the word if. ETH. Now, after writing the prefix "eth", we must add the suffix "ene" since the compound is belong to alkene family. So ETH plus "ene" is equal to ethene. So the compound that was given is the name of it is ethene. Okay, ethene. Now, how to get the molecular formula? First thing to do is count the number of carbons. So the given here has two carbon atoms. So the carbon here is 2. Now, use the equation. The equation of alkene is CnH2n. Third, substitute the equivalent number of N. N is the number of carbons. So 2 is the number of carbons. So CnH2n. So the N will be substituted with 2. Same with this one. So it will be C2H2 open parenthesis 2 close parenthesis. So the 2 parentheses will be multiplied to the number 2 after H. So it will become C2H4. And this is the molecular formula of ethene. Ethene, C2H4. That's how we're going to get the alkene molecular formula. Okay, now let's go to the full structure. First is count the number of carbons. So the number of carbons in ethene or C2H4 is 2. So there are 2 carbons. Next step is to write the carbons. So write the letter C's. Third one, connect the carbon with double bonds since they are alkenes. So in this case, it is only 2 carbons, then we must put double bonds here. Okay, double bond. So the fourth step is to pair it with hydrogens. Note, hydrogens are placed at the top and bottom of the carbons. So in alkanes, the last carbon and the first carbon will contain 3 hydrogens. But in this case, for alkenes, the hydrogen will be placed at the top and at the bottom. So the molecular formula, I mean the full structure of alkene is something like this. 2 carbon with double bond and there are 2 hydrogens at the top and at the bottom. So this is the full structure of alkene. Now, let's go to the condensed structure. So divide them based on every carbon that is paired with hydrogens. So the first carbon it has 2 hydrogens. So CH2. Then, since there is a double bond and it represents the alkene, therefore, in writing the condensed structure, we must also write or put double bond. So after double bond, count the number of carbons. 1, so C, and then H, and then duha man kabuok, therefore we're going to put 2 here. So this is the condensed structure of ethene. Yes. Okay. Let's proceed to the second example. The given here is 1-propene. Now, what is the molecular formula of 1-propene? What is its full structure? What is its condensed structure? And what is its skeletal structure? Now, let's go to the molecular formula. In molecular formula, first thing to do is check the name of the compound. The compound here is propene. So propane is the name of the compound. The prop is equivalent to the prefix 3. So prop is equivalent to 3. Therefore, the number of carbon is 3. So you already identified the number of carbons. Now, After that, the second step is you are going to use the equation. The equation of alkene is CnH2n. And after that, the third step is substitute the equivalent number of N. N is the number of carbons, and the carbon here is 3. So CnH2n, then the N will be substituted with 3 since it is the number of carbon. So it will become C3H2 open parenthesis 3 and close parenthesis. So the 3 here will be multiplied to 2. So it will become C3H6, and that is the molecular formula of 1-propene. Okay, this is the molecular formula of 1-propene. Now, let's proceed to the full structural formula. The first thing you need to do is to identify the number of carbons. And getting the full structure, you must get the number of carbons. So the number of carbon here, C3H6, is 3. Therefore, we must proceed to the step 2. We must write the carbons. Since there are 3 carbons, therefore we must put 3 letter C's. 1, 2, 3. After that, the third step is, since the name of the compound is 1-propene, you will put double bond in the first carbon. So the indication, hello, okay, I mean the purpose of this number in the given is dira nimo makitaan kung asa ang double bond. So, sa ika number 1. Ika number 1 nga carbon. Okay, first carbon. Now, the number in the name is where you can find the double bond. Note, the number are based on the carbons. So in making a full structure, again, in making a full structure, kung ikay maghimo, the counting must start from left side. So ang counting sa number magsugod sa left side. So this is carbon 1, carbon 2, carbon 3. Now, the given here is 1-propene. So kaning number diri nagrepresent na kung asa nimo makit-an ang double bond and naa siya sa first carbon, which is kani. So magbutang ka og double bond dira, then the rest is single bond. So inga na yang forma. After getting the double bonds and single bonds, you must put the hydrogens in it. So one for, I mean, every carbon na siya isa ka-hydrogen sa babaw and usa ka-hydrogen sa ubos. So, kung atong i-check, C, tulo ka C, and unom ka H. And it will equivalent to C3H6. So, mauni ang iyahang full structural formula sa 1-propene. Okay, gets? Okay. Now, let's get the condensed structure of propene. So 1-propene, the first thing you need to do is divide them based on the carbon that is paired with hydrogens. Now, this is the full structure of 1-propene. We are going to get the number of carbons and also hydrogens per carbon niya, okay? So first carbon na siya duha ka hydrogens. So therefore CH2. Now, the first carbon has a double bond. Then we must use double bond here. The second carbon contains 2 hydrogens, so CH2. And it is only single bond raman, therefore no need to put single bond here. It's only 2 or more. Okay? So CH2, and then usa ka carbon, duha ka hydrogen. Usa ka carbon, duha ka hydrogen. So this is the condensed structure of 1-propene. Okay, gets? Now, let's proceed to the skeletal structure. So 1-propene. Now, in writing the, let me get this. Now, ang given is 1-propene. So, in writing the skeletal structure, kuan magyuka. So, prop, arista, propane, or prop means 3. 3 carbons. Therefore, ang paghimo na to sa skeletal is na siya tulo ka edges. So, 1, 2, 3. Okay? Now, after that, ang kanang mga edges niya, amaw ng mga carbons. So, this is carbon, carbon, carbon. Now, basta kita gani ang mohimo sa skeletal o sa full structure, ang counting na to gikan sa left, mag-count ta sugod gikan sa left padung sa right. Okay? Now, if counting magani, therefore, this is carbon number 1, carbon number 2, carbon number 3. Okay, the given here is 1 dash propene. So, ang 1, dira ni mo makitan kung asa ang double bond. So, this is carbon number 1. So, padung siya sa carbon number 2. So, ang iyang double bond is something like this. Okay. So, mauni ang iyahang skeletal structure. The same sa gipakita nako diri sa iyahang structure sa PowerPoint. Okay? So, this is called 1-propene. Yes? Okay. Now, let's have another example. Example number 3. Example number 3 is 1, 3 dash hexadiene. Hexa means 6. Die means 2. So, naana siya die. It is because duha na kabok number. And 2 is equivalent to die. And the E here indicates it is alkene. Okay? No, it is called hexadiene instead of hexene. It is because the number on the right are more than 1. Or to be specific, it is 2. So, magamit ta og die. So, if that is the case, you must use the prefix in writing the name. So, hexa means 6. Die, which is a prefix, prefix that equivalents to 2. Since there are two numbers here, the 1 and 3, so duha siya ka number. Pasabot na duha ka double bond. Then we must use the die. And E indicates that it is an alkene. Okay? Mao na yang naming. Now, find the molecular formula of 1,3-hexadiene and draw the full structure, its condensed structure, and its skeletal structure. So, mana itong mga missions. Now, let's proceed to molecular formula. First thing to do is to get the number of carbons in the compound. Now, check the compound's name. Hexadiene is a compound's name. The hexa is equivalent to prefix 6. So, therefore, the number of carbon is 6. So, 6 ang number sa carbon. After that, we're going to use the equation of CnH2n. Third step, substitute the equivalent number of n, and n is the number of carbons. So, from CnH2n, it will become C6H2, open parenthesis, 6, close parenthesis. So 6 times 2 is 12. Therefore, the molecular formula of 1,3-hexadiene is C6H12. Okay, so mani ang molecular formula. Now, in full structure, since we already knew the step 1 is to count the number of carbons, it is 6. Now, we must write the carbons. So, there will be 6 letter C's. 1, 2, 3, 4, 5, 6. And then, since the name of the compound is, 1, 3, it is error, 1,3-hexadiene, then you will put double bond in the first and third carbon. So 1, 3, first and third carbons. So the number in the name is where you can find double bond. No, the number are based in carbons. So in making a full structure, again, basta kita yung maghimo, magsugod tag counting gikan sa left side. Okay? So, first carbon, second carbon, third carbon, fourth carbon, 5 carbon, 6th carbon. So, ang given there is 1, 3. So first carbon na ay double bond, and sa third carbon na apoy double bond. So the rest, mga single bonds na siya. So after nimo mabutang ang double bond o single bonds, bot nga na nimo mga hydrogens. Tag-usa sa babaw ug ubos every carbon. Okay? So this is the full structure of 1,3-hexadiene. Gets? Okay, good. So in condensed structure, again, divide them based on every carbon that is paired with hydrogen. So the first carbon, naa siya'y duha ka hydrogen, CH2, and then naman siya double bond, mag-double bond ka. Then second carbon, CH2, and third carbon, wala man siya double bond, so no need to put double bonds here. So CH2 again, and after sa third carbon na siya double bond, we must put double bond. And then another is CH2, CH2, CH2. Therefore, the condensed structure of 1, 3 dash hexadiene is CH2 double bond, CH2, CH2 double bond, CH2, CH2, CH2. So, nga na ang iyahang condensed structure. Now, for the skeletal structure, nga niyang forma. Okay, pasap na tamo. Let's check. Okay, the given here is 1, 3 dash hexadiene. Okay, now hexa means 6 and 6 carbons. So therefore 6 kabok edges. So 1, 2, 3, 4, 5, 6. Now, basta kita gani ang mohimo sa skeletal o full structure, mag-starta o counting sa left side. So 1, 2, 3, 4, 5, 6. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So mo ni ang iyahang skeletal structure. Since naa may number, therefore, dira nimo makitaan ang mga double bonds. So, ang double bond, first double bond is naa siya sa first carbon. So, first carbon padong ni 3, ni 2. Okay? That's the double bond. Ilisa na ko ni black. Okay. So, this is double bond. And ikatulo is din na po double bond. So, ani ang iyahang forma sa skeletal structure sa kaning compound ang 1, 3 dash hexadiene. So, the same sa PowerPoint nga kung gipakita. Okay, nasayop na siya. So, supposedly, pasaka na siya nga nasayop na siya kuan butang. So, kani ang iyahang saktong answer. Okay? So this is 1,3-hexadiene. Gets? Okay. Now, let's proceed to the last example. So if the given here is something like this, again, note, if the given is the skeletal or the full structure, so in counting, you must identify first on where side to start count or counting, if it is left or right. So for you to know where to start, try to check every side. Okay, basta given niya skeletal or full structure, kailangan i-identify nimo kung asa ka mag-start, sa left back ka or sa right. Now, for you to know where to start, try to check every side. If we will start counting from left to right, ingani ang forma. So 1, 2, 3, 4, 5, 6. So after counting, identify what carbon is the first double bond. So ikapila nga carbon ang naay double bond. So nadaring double bond, therefore, the first double bond is in 4 carbon. Carbon 4, which is kani. If we are going to start from left, so if mag-start sa left, number 4 ang first nga double bond. Now, if arita mag-start sa right, atong i-check. So, yung ano na yung numbering 1, 2, 3, 4, 5, 6. So, the first double bond is in the carbon 1. So, pinakaunang double bond is nasa carbon 1 if mag-start ta sa right side. Now, i-compare na tong duha. Compare the left to right and right to left. From left to right, I mean, for left to right, first double bond is makita siya sa fourth carbon. Sa right to left, makita siya sa first carbon. So, if ma-identify na natong duha, select the lower number. So, sa left to right, ang pinakaunang double bond is nasa fourth carbon. Sa right to left, ang pinakaunang double bond is nasa first carbon. Since mas gamay si first, I mean si 1, compare ni 4, therefore, mag-start tag numbering from right to left. Okay? Since the first carbon is lower than fourth carbon in terms of number, then we must start counting from right to left. So, ang ani ang yahang numbering. Okay, so the correct counting for this case is from right to left. 1, 2, 3, 4, 5, 6. So, angan ani nga alkene is 1, first carbon, comma 2, second carbon. Hexa means 6. Then di means duha ka double bond, di. Then na may double bond, E and E. So 1, comma 2 dash hexadiene. So that's how you're going to name if the given is skeletal structure or full structure. So manitimanan ninyo ha. If kamoy maghimo, again, if kamoy maghimo sa full structure o skeletal structure, then you must count first sa left side. But if given na gani ang skeletal structure or ang full structure, ang imong buhaton para makaibaw ka sa name is to identify kung asa nga side ang pinakaduol nga unang double bond. So, manay-timan mo. Okay. So, yeah, I guess that's all my discussion, and I hope you gain some information or nakasabot tara. And if you have any questions or concerns, just PM me directly, okay? I guess that's all for today. Thank you and goodbye, class or everyone. Thank you so much. Bye-bye.